In this video, we're looking at a strategy that can potentially save you a lot of time when you're solving problems, and we're going to call it plugging in numbers. It's a good strategy to use when your answer choices contain variables and when you have percents or fractions or ratios in the question, but no actual numbers. You can also do this sometimes when the answer choices are percents and the question is phrased in a particular way. When you're plugging in numbers, and we'll look at this in a second, but 2 is a good number to try because it's a small, simple number to work with. If you're picking a number to plug in, you don't want to pick 0 or 1 because it can make an answer look correct when it isn't. So avoid using 0 or 1, but simple numbers like 2, 3, and 4 are good choices. Let's look at a couple of examples so that we can get the hang of this. The first question asks us, if y is equal to 10 minus x, what is 4x plus y equal to? We can see that we have variables in the answer choices, and solving this problem normally would require us to use some algebra. So this is a good candidate for plugging in numbers. So here's what the process looks like. First, we notice that all of our answer choices just contain the variable x. So we want to pick a number to plug into the problem for x, not for y, even though we have both x and y involved. So let's say, for instance, that we pick the value x equals 2. Again, we don't want to pick 0 or 1, so let's go ahead and try 2. Then we want to work through the problem, assuming that x is equal to 2. So if we take the equation y equals 10 minus x, and x is 2, we're going to get 10 minus 2, or 8, on this side. So we'll get y is equal to 8. Now we have a pair of numbers, x equals 2 and y equals 8, that act as a solution to this system. What we want to do is take those two and plug into the second half. So what is 4x plus y equal to? Well, we already know x is 2 and y is 8. So 4x plus y will be 4 times 2 plus 8, or 4 times 2 is 8, so we get 8 plus 8, and that's 16. So now what we do is we say that when we plugged in x equals 2 and y equals 8, we got a value of 16. Which means that when we plug x equals 2 into our answer choices, we're looking for a value of 16, a matching value to the answer we got here. So if we take x equals 2 and we plug it into each answer choice, here we get 3 times 2 is 6, 6 plus 10 is 16. So we get 16, that matches our answer choice, so answer choice A is probably correct. We need to make sure, though, that none of the other answer choices also produce a value of 16. So here we get 3 times 2 is 6, 10 minus 6 is 4. Here we get 2 times 2 is 4, 4 plus 8 is 12. And here we get 2 times 2 is 4, 8 minus 4 is 4. We were looking for the value of 16. This is 4, this is 12, this is 4. So we can eliminate these answer choices, and answer choice A has to be the correct answer choice. If you get multiple answer choices to match the value that you found, so let's say, for instance, that answer choices A and B had both returned a result of 16, then what you want to do is go through the process again and pick a different value for x. So maybe instead of x equals 2, we could choose x equals 3, go through the whole process to find a corresponding value for y, get the resulting answer down here, and then just test answer choices A and B again and see which one matches that new result. So if you get 2 answers that both match, just go through the process again with a second value, and whichever answer choice matches both values is the correct answer choice. Now we can also go through a similar process with percent questions. So in this question, we're told, for an online boutique, sales increase by 40% in the first year, then by 20% in the second year. By what percent have sales increased overall? So because we see that this is a percent question, this could be a good candidate for plugging in numbers. Now, when we plugged in numbers over here, we picked a value of x equals 2, and that's always a good value to pick. But when you're dealing with percentages, you always want to pick a value of 100%. And that's because it's going to make the math really easy. So let's see what we mean here. If we start with a value of 100% and we assume that the boutique's sales started at 100%, then it says sales increase by 40%. Well, 40% of 100 is just 40. So that means sales increase by 40% in the first year. So at the end of the first year, sales are now 140% of what they were originally. Then in the second year, sales increase by 20%. Here, we're starting with 140% at the end of the first year. So we need to now find 20% of 140. Well, 10% of 140 is 14. So 20% has to be 28, or we could have just done 0.2 times 140, and we get 28. So 140 plus 28 is 168. So at the end of the second year, sales are now 168% of what they were originally. So the question is, by what percent have sales increased overall? Well, to get from 100% to 168%, sales have to have increased by 68%. And so we can go to the correct answer right away. So just remember that when you're going to use plugging in numbers, if you have a problem like this one, go ahead and pick something simple like 2, 3, 4, a number like that. But if you have a percent question, the number you want to start with, the number you want to plug in, is always 100%.